Okay, so today we're going to show how to operate our file. So we need to import it, projects from folder archive, then we can go to archive. We already have our folder, zips folder downloaded. We open up from there, and then you just open it. And then from the SRC, you go down. You probably want to first reset the scores, and then you can play the game. And that is how it's done.
Hello, this video will cover our final project for ECE373. Our project is the Galactic Peacemaker. We are Team 6, which consists of Bryce Johnson, Jared Rickle, and Oliver Sjostrom. So to give a brief overview of our project, our game is heavily influenced by the arcade game Galaga. Our game consists of a single-player ship that can move in 4 directions: up, down, left, and right. It can fire projectiles using the spacebar. You will battle against 50 different and unique rounds of enemies. Where then, if you beat all of them, you will win the game. Um, Obviously, if you lose all life, then which you lose life from colliding with an enemy projectile, you will be greeted with the game over screen. If you score a high score, then you can enter a name that corresponds with that score, and it will then be saved in the game. Um, in each round, the enemies can move in one of 3 patterns. There's the standard formation, where the enemy moves um, as one unit horizontally. There's the rotational movement pattern, where the enemies move in a circular motion. And then there is the freestyle movement pattern, where the enemies move randomly. Upon death, enemies have a chance to drop one of 5 power ups, um, which are the weapon up power up, which upgrades the weapon of the player, the nuke power up, which completely wipes all enemies on a single round, the health up power up, which restores 1 health of the user, um, the slow power up, which slows the entire game down, and then finally the damage up, which increases the damage of the user's projectiles by 1. The players and the enemies can equip one of 3 weapon types. This includes the single shot, the double shot, and the spray shot. The single shot, um, the single shot, as it sounds, shoots 1 projectile, alternating from either side of the player's ship. The double shot shoots 2 projectiles simultaneously from both sides of the ship. And then spray shot is the double shot, but then on top of that, will also shoot a diagonal shot from the right and a diagonal shot to the left. On startup, the player is going to be presented with the main menu, and the main menu gives the options to either start a game, view the high scores, or get a tutorial. The tutorial will open a page which then explains the basics of the game. Okay, next I'll talk about our use cases. So the use cases that directly are associated with the user is picking up a power up, getting hit by a projectile, setting a high score, providing an input, and the starting menu of the game. So the picking up a power up can be generalized into the nuke power up, upgrading the weapon, increasing damage, the slow power up, and gaining a life. If the player is hit by a projectile, they can lose a life. If they run out of health, the player dies, where then the game ends. If the player wins, the game will also end. If the player sets a new high score, then the use case to enter a username is triggered. From the providing input use case, the player can pause the game, where then they can either resume or end the game. Um, if the user can also shoot, where then if the projectile hits an enemy, it has the possibility of killing the enemy, which then the enemy has there's a probability of the enemy dropping a power up. The player can also trigger the movement use case. Then the game will check if um, the movement is permitted. Um, where then if it is, the player moves. So the starting menu refers to the GUI that is displayed at the startup of the game. From there, the player can either view the tutorial, view the high scores, or start a game. So to go over the use case descriptions, so our first one is the starting menu. So this refers to the GUI that the user is greeted with to begin with. This GUI gives options to either start a new game, view a tutorial, or view the high scores. Um, the user From there, we have the use case starting the game. This is exactly what it sounds like. Um, if the user starts a new game, the executable will begin a fresh run of the game from the beginning. Um, the exception here is that the user can end the executable. Our next use case is the pausing use case. The player can do this by pressing the P key, which I'll change right here. Change the P key, selects the P key, which will then pause the game and freeze all moving components. Um, the player can then resume by hitting P again. The exceptions to this use case is if the user ends the executable or if the game over screen is displayed, then they won't be able to pause it. Our next use case is the view high score. This refers to the GUI that shows the top 5 high scores of the game. The exceptions are the no recorded high scores or if the user ends an executable. The next use case is setting a new high score. This refers to the player dying or winning and scoring um, a new high score, which is determined by killing the enemies. There are no exceptions to this use case. The use case enter username refers to entering a username that corresponds to the new high score that the game can save the score the under. The exception here is if the user enters an invalid username. Our next use case is the viewing the tutorial. This refers to the GUI that is shown uh, if the user selects the view tutorial button from the home screen. This GUI will show the basic controls of the game. The exception here is also if the user ends the executable. Next, we have the back use case. This use case refers to backing out of um, either the tutorial or the high score page. Um, this this use case will bring the user back to the home screen. The exception here is also if the user ends the executable. Next, we have the provide input use case. This refers to any sort of keystroke that the user enters. The exceptions here are invalid keystroke or multiple keystrokes. Next, we have the movement use case. This use case triggered if the user enters either W, A, S, or D. Allow to move is the use case that refers to the game checking whether the player is permitted to move. The exception here is if the player is out of bounds. If they're out of bounds, then they will not be allowed to move. Our next use case is move. This is exactly what it sounds like. The player moves. There are no exceptions here because at this point, all the exceptions have already been caught. Our next use case is shooting. This refers to the player pressing the space key, which would then shoot a player projectile. There are no exceptions here. Okay, our next use case is the hit enemy use case. This refers to the enemy being hit by a player projectile. There are no exceptions here. Our next use case is the player gets hit by a projectile. If this happens, the player loses a health. Um, if the exception here is if the projectile is not an enemy, then the player will not um, lose. The collision will not trigger. Also, if the not in game exception refers to if the player isn't actively in the game, playing or unpaused, collisions with projectiles will not trigger responses. Next, we have the lose life use case. This just refers to the player losing life. Um, if the exception here is if they don't have enough life, then the game will end. The player will die. Also, the not in game exception that was stated before. Our next use case is die. This happens if the player loses all their health. The exception here is obviously if they still have hearts, then they will not die, and if they are not in game. Next, our next use case is wins. This happens if the player beats all of the rounds. The exceptions here is if not all ships are destroyed, then obviously they don't win, and all lives are lost, then they'll actually die before they win. Our next use case is kill enemy. This happens if the enemy loses all their health. This happens if there are no exceptions here. Our next use case is the dropping the power up. This happens when an enemy has died. The exception here is um, the power up has not been generated because since um, the possibility of them dropping a power up is completely up to a RNG. So there's a chance for no power up to be dropped at all. Our next use case is to pick up the power up. This happens if the user collides with a power up, where then a collision action will occur. Uh, the exception here is if the player is not in game. Our next use case is the nuke enemies. This use case refers to picking up the nuke power up. If they pick this up, then every enemy is wiped from the round. There are no exceptions here. Our next use case is upgrade weapon. This refers to the weapon up power up. This upgrades the player weapon from single shot to double shot and double shot to spray shot. The exception here is if the weapon's already at spray shot or maxed out, then it will not be upgraded any further. Next, we have the gain life use case. This refers to the health up power up, which restores one life of the player. The exception here is if the life is maxed out, then the player cannot gain any more life. Next, we have the upgrade damage use case. This refers to the damage up power up. This increases the damage of the player projectile by 1. There are no exceptions here. Then our final use case is a slow game. This refers to the slow power up, which if the player collides with, it will make the entire game in slow motion. And there are no exceptions here. Okay, next we're going to move to the sequence diagrams. So for the player starting the application, the user is going to start a new game, and then from the game class, we're going to create a new audio player, a new home screen GUI, a new tutorial screen GUI, a new high score screen GUI, and finally a new space GUI thread. Our next diagram is going to be the player navigating to the high score screen. So it's going to move from the button listener, where the action performed is going to open the home screen GUI, and then finally we're going to run the show high score function, which is going to actually display the GUI to the user. To navigate to the tutorial screen, it's going to be the same exact story, except we're going to show the tutorial GUI at the end. For the creating a new game, the action performed from the button listener is going to move to the home screen class, where then it's going to tell the game to show a game, and then we're going to start the space GUI thread. Our next diagram is entering a name for the high score. So once we get to the you win screen GUI, we're going to move to the high score object class, where we're going to enter a name, and then it's going to check if the name entry is valid. If it is, it's going to move to the home screen by running the function add and save the name. Next, we have the player moving. We're going to start from the space GUI class, where if it detects a key pressed event, then it's going to go to the space game class, which is then going to handle the move function, and then from the which then goes to the player ship, and then the space game is then going to repaint, which will then show the the changing coordinates for the player ship. For the player shooting the projectile, it's going to be really similar, except the user is going to press the space bar as the key event. Then the space game will then process that and run the shoot function. The player ship will create a new projectile. The projectile will add itself to the space game, and then the space game will then repaint to show the new projectile. For the player pausing, if the space GUI detects a the P key being pressed, then the space game is then going to basically enter a while loop while this is pause flag is high, and everything will be frozen. Next, we have the player's hit by projectile and loses life. So the space game, on one of its iterations of checking for collisions, if it detects a collision between an entity, then the collision action will then be run corresponding to the player's ship. The player's ship will get the damage from the projectile, and then the projectile will return the damage to the player's ship, which will then get subtracted, which will then be subtracted by the player health. Next, we have the player losing. So the player's ship class will return the health to the space game. The space game will then evaluate its health. If it's equal to 0, then the controller of the game class will then display the lose screen to the game over, which will then move over to the game over class, which will then run the show function, which will display the GUI to the screen. Next, we have the enemy being hit by projectile but doesn't die. So the space game is going to check for a collision. If it detects a collision between an entity, then it's going to run the collision action for the enemy ship, which will remove its health. Next, we have enemies hit by projectile and dies. It's going to be the same exact sequence, except then the to be destroyed flag is raised high, and then in the next iteration, the space game will prune this this entity. For generating a new round, if the space game evaluates the enemies list to be 0, then the round driver will run the function get next round, where then the next round will then start itself by running the start round function. For the player wins use case, if the space game evaluates the enemies list to be equal to 0, then the round driver will get the next round. The current round will then, or if the current round is null, then that means that there are normal rounds, and then the controller game will display the win screen. For the enemy dropping a power up on death, so when the space game runs the purge components, it will generate a power up. If the random number generator determines that a power up should be generated, then a new power up is created, and then the power up adds itself to the space game list, the space game power up list. Next, we have the player picking up a nuke power up. So here, the space game checks for collisions. If it finds a collision between an entity, in this case, it's the player and a nuke, it's going to run the collision action, which is to wipe all enemies from the round. The player ship will trigger the nuke, which raises the nuke flag high, and then on the next iteration, the space game will then purge all enemies from that round. Next, we have the player picking up a health power-up. So it's going to be the same situation here, except at the very end here for the collision action. This collision action for the health power specifically will increase the health of the player ship by 1. It is the same exact sequence for the slow power up, except here it's going to trigger the player ship will then trigger the slow, which then in the next iteration, the space game will then slow down the thread to give the image of, or to give the impression of everything being in slow motion. So for the player picking up a damage power up, it's also the same sequence until the very end, where the player's ship will increase the damage of its projectiles. Next, we have the player picking up a weapon upgrade power up when they have a single shot. Same sequence. The collision is checked. The collision action is ran. This collision action will create a new will equip the double shot weapon to the player's ship. It is the same idea here, except now it's going to equip the spray shot instead of the double shot. Okay, for our last sequence diagram, we have the enemy shooting a projectile. So the space game class will run the function shoot, which will cause all enemies to shoot. The enemy ship will then create a new projectile, and then the projectile will add itself to the current game. And then finally, the space game will then go to the space GUI where everything will be repainted. Okay, so for our domain class model, I'm going to zoom in a little bit. So obviously there's a lot of classes here. We have our game engine here, space game, which has the attribute current stage, which is of class round. The round is then consists of the round data and round driver. The pattern attribute of the round is of type movement pattern, which freestyle, rotational, and standard formation all extend from. The ship data is actually a private class within the freestyle, so that's what this association is showing here. We have the entity class, which is a very important one. It's an abstract class where basically all the functional components of our game inherit from. So we have the explosion, which is the animation for when basically whenever a projectile hits a ship. We have the star entity, which is the white specks that you see in the background that you'll see later in the demo. We have the ship class, which is also abstract, which the enemy ship and player ship extend from. The enemy ship and player ship both make use of the weapon class, which the single shot, double shot, and spray shot all extend from. Projectile also extends from entity, which is also related to the space game player projectiles and enemy projectile lists attributes. Power up is also extends from entity, and it is also abstract. It is also related to the power up list in the space game, which basically keeps track of all the power ups that are currently active. The nuke, health up, weapon upgrade, damage up, and slow are all classes that inherit from the power up class. Next, we have the space GUI in the game. The game is basically the most top level class we have. It has the space GUI thread and delay thread. The delay thread is responsible for delaying the game. And the game attribute is of type space GUI thread. The space GUI is, as it sounds, is responsible for all the GUIs and showing all the GUIs for the game. The game is actually responsible for starting the game, creating the GUI, and starting the actual game engine. Um, the GUI panel class is a part of the space GUI. Um, its attribute main panel is of type JPanel background, and game over, tutorial, home screen, high score screen, audio player, set high score, and you win are all GUI related classes that all extend from the GUI panel class. Um, so there were some modifications for our classes, but and many additional classes added. The two big areas where there were a lot of classes added were mainly the graphics and the classes required for restructuring the game engine mechanics. But also sort of quality of life things like explosion, stars, just to make the game look a little better. So I won't dive too in depth here, but here are all of our classes. One of the very important classes here or functions is the check collision, which calls check intersection, which then calls checkpoint, where then if there's any collision detected, it will run this collision action, which is an abstract function that is inherited by all of the classes that extend from entity. And this is where we determine what sort of action should be taken when two entities clash, such as a player projectile and an enemy ship. Um, Here we have the player ship, or we have the ship class, which then extends into the player ship and enemy ship. We have the star, the explosion, the weapon class, which extends into the spray shot, single shot, and double shot. We have the movement pattern, which then extends into the standard formation, rotational, and freestyle. So for all three of these classes here, the increment is the function that actually is responsible um, for is basically what iterates all of the enemy movements, and so that's why each one of these movement pattern classes have it. Um, we have ship data, it's a very small class. We have the round class, which is responsible for generating the enemies in each round. We have the round data, which just stores all the data of the round. The round driver, which basically creates all the rounds at initialization. We have the space game, and this is our game engine. We have a few static variables such as final score, which is it's needed to be static um, because how we store our high scores. We have the player height, which stays the same, the game width and game height that also are constant. The test flag here is just used for testing, so it would be set to false for when we actually when we run the game normally. Um, the enemies, player projectiles, enemy projectiles, power ups, stars, and explosions are all linked lists that store all instances of each respective entity, and that is how we keep track of what is currently displayed on the screen. Here we have the game class. So this is our highest level class. So as you see here, it's keeping track of the J frame, the main view, home screen tutorial, high score, game over, you win. Also has the game, which is of type space GUI. So this game is actually responsible for basically starting everything from the GUIs to the actual game, which we see right here from the start game function. So this start game function is actually called when we call the game constructor. So creating a new instance of the game automatically starts our game. We have the GUI panel class, um, the high score screen, which then um, actually, let me make this abstract. So the high score screen, home screen, um, tutorial screen, game over, and UN all extend from the GUI panel class. So the GUI panel class is just kind of our our parent class for displaying a screen to the user. We have the button listener, which is just the way we listen to what option the player picks from the home screen. We have the delay thread, which is we use to delay the thread whenever we need. We use this sometimes for we do use it for the slow power up, and also for yeah, I believe just a slow power up. And then we have um, the space GUI, which is responsible for all of the GUIs of our game. It extends JPanel and it implements key listener. This is crucial because we have the GUI supports buttons, which is why we need this key listener. We have the tutorial, already said the tutorial screen. Then finally, we have the high score object. This class is responsible for keeping track of all the current high scores we have, which we see in this get top 5 elements function and this add and save function that we saw earlier in the sequence diagrams. Okay, next I'm going to move on to our activity models. So we're going to have 2 of these. So for the first one, this is more of a macro view of our code. So from the entry point, we're going to start the game, which is going to open the game, display the main menu or the home screen, which is what we called it. From here, we can either watch a tutorial or we can view the high score. Either way, if you go back or open tutorial, we go back to the home screen. From there, we can also run the space game, where then it generates a round and then it runs the game. If the P key is pressed, then it displays the pause menu. If P is pressed again, then it goes back to run game. If the player dies, the game over screen is displayed to the user. If the player gets a high score, then a high score screen is displayed. If an invalid name entry is entered, then it's going to stay in this state. If a valid name entry is entered, then it's going to record the high score. It's going to go back to the home screen. If we choose to quit at any time, then the game is terminated and we exit. Now for a more micro view of how the game engine is running. So from the run game, it concurrently checks if there's collisions, which is all these, as well as repainting all the components. So if there's a projectile and enemy ship collision, then we remove enemy life. We'll kill the enemy if the enemy has no more life, and then if it is randomly generated to generate a power-up, then we can generate a player weapon up, health up, slow power-up, or a nuke. From a projectile and player ship collision, we will remove a player life, and then if there's no more health, then we kill the player, where then we enter the exit condition. If else, then we just go back to running the game as normal. If we nuke all the enemies, then it automatically generates a new round. If we kill an enemy, and there's no more enemies, it will also generate a new round. If there's no more rounds, then we display the win screen, which then the exit condition is reached. There is also, from the run game, if we ever press the space key, then the player shoots a projectile here. And then if we press a WASD key, then we move the player. Both cases, we go back to the run game state, where then it keeps running. Okay, so for the last part of our report, it's going to be the state diagram. So from the entry state, from our entry point, we enter the state initial page, which displays the home screen. From here, we can either go to the high score page, the tutorial page, or start the game. So here, where we game in it. If from here, if the game is ever determined to end because there's no more rounds, or if the player dies, We go to this game over state, displays a score, and allows the user to enter their name. Then it goes back to the home screen. So from the game init, it creates a new round, and then it's going to move everything, or all the components in the game will move. Then the game will check for collisions. Then next, it's going to purge all components. The purge components just purges anything that has its delete flag high, which happens in the previous iteration. After there, it's going to paint everything, and then it's going to go to game eval. Here, it's going to evaluate whether if there's any more enemies, and a new round should be created, and of that sort. Next, or from the game eval, will also evaluate if the player has any more health. If they don't, then obviously the game goes to the game over state, where then we go into the state before. From the move everything, if the player ever presses pause, then we enter the pause game state, where it will remain in that state until we press P again, where then it will go back to checking the collision, and then keep looping in this cycle until a game over condition is reached. From the check collisions, we can also, if a collision actually does occur between a ship and an entity, then we will enter the ship gets hit state, where then we'll decrement the health. If the health is greater than 0, then we'll continue and then go back here, check for collisions, and then get back in the cycle. If the health is less than or equal to 0, then we'll set the delete flag high, where then we'll add the power up if the ship is an enemy ship and the random number generator determines that the power up should be added. Then we'll go to continue and then get back into the loop. And here we have the state descriptions. These, I already explained what each of these do, so I won't explain that again. But yeah, that is all for the report, and now we will cover the demo of our game.
So, hello everyone, my name is Oliver Sostrom. Now that Bryce has run through all of that, I'll be going over our use cases and doing a quick demo of the functionality of our game. So starting off, this is the main menu screen. We see we have a couple buttons. One is the new game button. This will actually start a new game. We have the view high score button, which clicking it will show the user the top 5 recorded high scores. We actually record every high score. We just choose to populate the top 5. Clicking the back button is going to return us back to the main menu. Then we have the tutorial button. This just gives you basic tutorial information, WASD to move, spacebar to shoot, P to pause, and then your overall mission as a Galactic Peacemaker. I'm just going to jump into the game real fast, just to show you some of the more, negative use cases. So starting a game, it's with WASD to move, spacebar to shoot. You can see we're restricted here on the outside boundary. We can't go past and we can't go up a certain distance. And then I'm going to start taking damage. You can see the little explosions effects, and my life down here in the corner is incrementing. One quick note is I actually turned off the music, mostly because my audio setup, it will make it really, really, really loud. But I'll add some clips in at the end just showing the music. Probably not every situation, so if you want to see every situation the music changes, you'll have to play the game for yourself. So I get hit one more time. We come to the game over screen. I can add a high score. We have some basic exception handling on this page. If you don't enter a name, you get an error. If you enter too many characters for a name, you get an error. So I'll just enter sad because I'm very distraught that we lost. So I'll submit that, and it redirects you back to the main screen. So that was just going over the start menu use case, start game use case, the pause use case, view high scores new use case, set new high score use case, enter the username for that new high score, the view tutorial, the back button, the provide input, the movement, the allowed to move, which is the specific box that constrains the player model, the player hit by projectile use case, the lose life, and finally the die. Alright, so now I'm going to run us through some of the positive use cases. So I'm just going to jump into the game. So, new game. Okay, so hopefully I win. I did actually lose, so I made the game easier, because I'm not a natural born Galactic Protector, apparently. So you can see me just moving around, shooting enemies. You can see them exploding. That's the die use case. You can see I've collected a power-up, which empowers my weapon. Here's another power-up, which empowers my weapon again. You can see I have now 4 shots. There are only 3 weapons in the game, so collecting another one won't really do anything, but we can do it for fun. We can also see in the corner the rounds and the score are ticking up as we go. That's really fortunate. This is a damage power-up, which empowers my weapon more. You can see the guys dying much faster now. And then we'll just keep murdering. Here's the nuke power-up. It kills all the enemies on the screen. And then we got lucky. We can chain them together. And then here's a health power-up. You can see when I collect it, my health goes up. So we'll just keep doing this. And then here's the slow time power-up. Again, a nuke power-up. I'm getting very, very fortunate with power-ups here. I actually didn't change the spawn rate of these. So that's pretty lucky. So you can see I'm just blasting away. We can chain the nuke power-ups together just to clear this a bit faster, saving lots of lives. Here we go. And these guys, you can also see we have a lot of different ship models, a lot of different weapons, a lot of different movement patterns. So let me just clean this up real fast. I did decrease the number of rounds, so we shouldn't be here too long. I believe this is we're close. Go. We're getting there. The full release though has a lot more rounds, a lot more ships. So you just have to discover that on your own. Another health here. Waste some time. Very nice. I believe this is the last set of ships. Just chaining the slow time power-ups together. Makes dodging the projectiles significantly easier. Power-up. And there we go. That's the end of the game. So again, we can add the scores. I noticed in the last clip with the recording software I'm using, you can't actually see the pop-ups, but they are there. So we're going to have another clip at the end just showing those pop-ups. But they do happen always. It's just with the capture software, I can't really get that, unfortunately. So yeah, that's all the positive use cases. That's moving, that's shooting, that's hitting enemies, that's winning, that's killing enemies. That's the enemies dropping the power-ups, us picking up the power-ups, and then just a demonstration of all 5 of the power-ups. Thanks. Alright, so now to actually demo the audio, I'll show 2 situations. There are a couple more situations where it changes. As a heads up, this is pretty loud, so I would recommend turning down your audio now, in case you forget to adjust it and edit in.